There are also cases where it's not very obvious that we can apply L'Hopital, but we still can apply L'Hopital. Those are what I call here advanced examples. For example, the limit as x tends to 0 of x logarithm of x. So this is 0 times negative infinity, which is an indetermination, but not of the 4 types that we saw we can apply, where we can apply L'Hopital. Okay, so this is not covered by L'Hopital. But if we write this limit in the upper pit way, then we will be able to do it. What we do here is write the x, instead of multiplying, we are going to divide by 1 over x. Okay, multiplying by x and dividing by 1 over x is the same thing. But when I write it this way, the limit I get is negative infinity divided by infinity. And this is an indetermination, but this one is covered by L'Hopital. So here we can apply L'Hopital, limit as x tends to 0, 1 over x, the derivative of the logarithm, divided by negative 1 over x squared, the derivative of 1 over x. And if I simplify all this, what I get is the limit as x tends to 0 of negative x, because the x squared is dividing in the denominator, it goes to the numerator. So I get negative x, and then the limit as x tends to 0 is 0. So no problem anymore. We can do this in many examples, okay? So even if we can't apply L'Hopital right away, it's worth checking if there is any manipulation that can play in our favor. So for example, limit as x tends to 1 of 1 over the logarithm of x minus 1 over x minus 1. In this case, what do I get? I get infinity for the first limit, and for the second, it doesn't even exist. Okay. So this is an indetermination, but again, it's not one of the things that L'Hopital will handle right away. So we need to figure it out. Now, here, if we have two fractions, right? So if we do the computation, x minus 1 minus the logarithm of x divided by the common denominator, logarithm of x times x minus 1, now what we have is 0 in the numerator divided by 0. And this is one of the L'Hopital cases. So here we can apply L'Hopital, limit as x tends to 1, the derivative of the numerator is 1 minus 1 over x divided by, here we need to apply the product rule, 1 over x, x minus 1, plus logarithm of x times 1. Okay, and if I apply the limit now, what do I get? So I get 0 divided by 0. All right, so we still need to work a little bit more. The limit as x tends to 1, the derivative of negative 1 over x. Should I simplify it? Yeah, let's simplify before, because otherwise this is going to be painful. Okay, you can do the derivatives, but be smart. See if you can simplify. So x minus 1 divided by x minus 1 plus x logarithm of x divided by x. So we simplify the x's. This is still 0 divided by 0. Okay. So we can now apply L'Hopital, and it's a little more user-friendly. Okay. The derivative of x minus 1 is 1 divided by 1 plus the derivative of x logarithm of x, which is x times 1 over x. Wait. 1 times the logarithm plus x times 1 over x, the derivative of the logarithm. And here, when I plug the value x equal 1, the logarithm of 1 is 0. And then here I have 1 plus 1, so this is 1/2. And that's the value of the limit.